Well, good morning, ladies and gentlemen. I'm very pleased to be talking with you. Thank you to the sponsor and the organizers of YIS, and a special thank you to Thor, who will be helping me with interpreting. Here we are having a meeting 6,000 kilometers apart, for I'm in Adelaide, South Australia. We can speak instantly. So, do we need writing? Well, yes, we do. Even the technology which joins us today would not be possible without writing. We need writing for the complex things in our lives. You're clever. You need to be good writers. Now, this is the fourth week of your program, I think. You've already heard a lot from the other presenters. So some things I say today might not be new to you. That's okay. They probably need repeating. We are scheduled for 2 hours. That's way too long to listen to a talking head. Our concentration spans are limited. So you have my sympathy. We do have some breaks, I believe. Now, in other sessions, in breaks, I understand you've done some exercises. We can't really do that. Writing is the kind of thing that takes time and needs a quiet place. Maybe instead in the breaks, you can ask me any questions you like that you think I can answer. Now, understand that I'm a specialist in language and linguistics. I've also worked in 7 countries, mostly in the Pacific and East Asia. And I've got a pretty good general knowledge of the world. I'm not a specialist in science, technology, engineering, and math. I've got a general understanding of those. Now, the material that we present today will be published later, and YIS can later give you a link to that. And Niavo has also agreed to make a translation and have that published. At the end of the material, there are 3 assignments for you. I encourage you to try the assignments, right? They are follow-up from what we're doing here. Okay, now let's get on with the topic. I've called it How to Write a STEM Paper, illustrated with a simple experiment. Let's switch away from my head. There we go. Now, we have a lot of PowerPoint slides. We have an expression in English, death by PowerPoint. I hope you don't suffer too much. All right. So let's look at this. I'm sure you already know this, but formally in a STEM paper, there are certain parts. The first part is an abstract, the second, then an introduction, then methods and materials, then results, then a discussion, a conclusion, and a reference. So using my own little experiment, we'll see what the sort of thing that can be inside all of those. So this presentation will contain all of those sections in a basic form, only a basic form. And in this way, we can demonstrate how a STEM paper works. So the STEM paper here will also report on a simple experiment, very amateur. The experiment is only an illustration, right? In fact, everyone's invited to repeat the experiment, right? Repeating experiments is the best way to test them. Some sections in this presentation will contain extra explanations to help new researchers and students. Of course, you will not find those in a normal STEM paper. Now, when I began to put this talk together, I found a really useful reference on the internet. It's an excellent short summary of STEM writing from Indiana University in USA, and it's called Writing a Scientific Paper. So I'm going to quote from that summary at the beginning of each section here. You can check out the link later. So, quoting from the Indiana University summary about abstract. Now, remember, abstract was the first item in your STEM paper content. Abstracts are a summary of the research as a whole and should familiarize the reader with the purpose of the research. Abstracts will always be written last, even though they're the first paragraph of a normal STEM paper. So, unlike a lab report, which are often internal, all scientific papers will have an abstract. They're going to be read by strangers. So when you're writing an abstract, quoting from Indiana still, you try to answer these questions. Why was the research done? What problem is being addressed? What results were found? What are the meanings of the result? English mistake, should be meanings, or what is the meaning, if you like. How is the problem better understood now than before, if at all? Okay, now from my simple experiment or sample experiment, my abstract is this. A simple experiment of hand grip strengthening was conducted to illustrate principles of scientific research. Okay. The experiment addressed other research findings that eccentric muscle contraction is superior to concentric muscle contraction in terms of duration and frequency in increasing muscle strength. That means nothing to you at the moment. We'll explain it in a few minutes. Okay. The experiment was conducted over 46 days by a single subject, that's me, using his left hand to measure strength changes from using concentric contraction, and his right hand to measure strength changes from using eccentric contraction. Hey, this is what I used to make my muscles stronger, like a squeezy thing, right? And later I measured it, I used a thing called a dynamometer to measure the strength of my contraction. We'll look at this more in a few minutes. Well, the experiment failed to demonstrate any significant change in grip strength using either eccentric or concentric muscle contraction. However, as an illustration for you guys, the experiment served its purpose. So remember, this is my abstract of what I'm giving to you. It's an example. Now, what about the introductory section of your STEM paper? Well, going back to Indiana again, the introduction of a scientific paper discusses the problem being studied with and other theory that is relevant to understanding the findings. Hey, sorry, my eyes keep slipping sideways. The camera is to the left a little. So, yeah, never mind. The hypothesis of the experiment and the motivation for the research are stated in this section. Write the introduction in your own words. Yeah? Your words. Try not to copy from a lab manual, yeah, or some other guidelines. Instead, show comprehension, show you understand, comprehension of the research by briefly explaining the problem. Okay, now I'm going to go sideways a little bit and put in some extra material here. From your other presenters, you will have heard their ideas of scientific research. I'm going to go over this because I think it is important. So for a few slides, we'll go over what is scientific research. So in this introduction, section 1, what is scientific research? Section 2, scientific method. And section 3, explanation. These will not be found in a normal STEM paper, of course, right? However, it's essential to understand them. So, at bottom, scientific research is a process of testing ideas to see if they work reliably in the real world or in a model. Most scientific research is done following standard rules of procedure, and it's also reported in a standard way. That is important. It helps people repeat the same experiment. Now, what is scientific research? Continued. Some testing is easy, but much testing is very difficult. You know, it might be easy to see if a simple machine works and, you know, how well it works. It's more difficult to test a complex machine like a computer because problems may be hidden, and also one problem can cause other unexpected problems. That happens a lot. Okay. It's often extremely difficult to test ideas about very complicated systems in nature. Examples might be the weather, climate change, the human body. Now, also, human beings themselves have created many systems. Some of these systems are very big and complicated. Examples might be, well, the economies of modern countries, or the public health system of a developed country. Now, depending on how hard the problem is, we use different kinds of investigation. The most direct kind of scientific method, it's often called a classical scientific method, is as follows. 1, exactly identify all the parts of a system which can change. 2, hold all those parts or variables constant except for one variable. 3, change this one variable to see what happens. An example might be changing one ingredient in a cooking recipe. Okay. Now, when we get complicated, the kind of scientific method used to study very complex systems usually cannot give a certain result. It can only give a probable result, a likely result. Why? Well, 1, it's usually not possible to study the whole of a complex system. Only one section of this system will be studied at a time. An example might be medical research. All right. I've read that the human body has 34 trillion, not million, not billion, 34 trillion cells, little factories, little animals holding hands, and about 100 trillion other organisms like bacteria, viruses, and so on in residence. Now, really, nobody can control all the variables in such a system for research. So researchers studying big, complicated, invisible systems often create a simplified model to test how they might work. Models are not perfect, but they are often all we have. Examples might be models of the universe, of the human brain, or, even engineers creating the scale model of a bridge. The methods used to study such very complex systems always require quite sophisticated data analysis, statistical procedures, sometimes artificial intelligence, AI. And even then, the results might be contradicted by more research. Remember, we're working with models. All right, well, that's our little distraction over. The remainder of this presentation will report on my simple experiment as an example of a STEM paper, right? The result of the experiment I do doesn't matter much here. Instead, the experimenter, me, the experimental report will show one example of STEM writing. In the future, you will probably write much longer and more complicated papers. However, the pattern of writing will be similar to the report here. Oh, here's another little aside digression. Even simple experiments take time and use resources. Both the experiment and later reporting will flow more smoothly if all records, information, and materials are carefully organized first. You're a project manager. For example, it's a very good idea to keep a project diary. I did this for this thing. A project timeline. When does it have to be done? A list of resources. What do you need? A directory of data files. Oh, and a list of contacts, people you need to talk to, work with. And last, above all, back up everything in case of accidents. Here you've spent 3 months, 3 years working on a project. The computer breaks, the files are lost. What do? Back it up. Keep a second record always. All right, now, our sample experiment used in this study. Our research question, my research question was, does eccentric muscle contraction or release, strengthen muscles more efficiently than concentric muscle contraction? Okay, let's explain what all this means. There are 3 known ways to make a muscle stronger. And the research tries to explore 2 of those ways. There's isometric contraction. That means putting a muscle under stress without moving it. For example, just standing in the street means that many body muscles are tense to keep balance. You're standing upright against gravity. Yeah. Now, the next type, concentric contraction, means that a muscle shortens when it moves to do work, like picking up a weight. Or in my experiment, we've got this squeezy thing. I squeeze the machine, and my muscles contract when I squeeze the machine, right? And then we have eccentric release or contraction, it's often called too. And that means a muscle lengthens gradually when it's released, like putting down a weight. Or with my thing, all right, here we go. It's squeezed, now I let it go slowly. So my muscles are hanging on while I let it go. And that's called eccentric release. Got it? And then later, I'll measure the strength of both using this dynamometer thing. Now, of course, I did some research on this kind of muscle contraction, and I found that in sports science, a guy called Nosaka in 2022, he's a Japanese researcher, suggested that eccentric release strengthens muscles more quickly than concentric or isometric contraction. If that's true, it's important because many people trying to get fit only concentrate on concentric contraction. They're lifting the weight and they think that's it, but it's not. All right. So lab reports and STEM papers usually contain an hypothesis. It's a formal statement of what you think will happen or won't happen. So a positive hypothesis would be this. It's hypothesized that hand grip strength can be increased, A, more quickly, and B, to a greater degree by concentrating on eccentric muscle release rather than concentric muscle contraction. Now, in fact, in most research, a negative hypothesis is used rather than a positive hypothesis. This is because it's often easier and more reliable to show that something is not the case than it definitely is the case. So in this demonstration, for example, a negative hypothesis might look like the following. Okay. It is hypothesized that an improvement in hand grip strength is not differently affected by whether work done by a muscle is in a concentric phase or an eccentric phase. All right. This is just an example, okay? You'll have to make your own hypotheses for your own research. And continuing with my sample experiment introduction, what happened? For the purpose of this experiment, over 46 days, twice a day, mostly, I was lazy sometimes, the researcher used one hand to squeeze a grip exercises slowly, then release it quickly. Okay, that's my left hand. My left hand is my strong hand. Okay, so I squeeze slowly, then release quickly. Squeezing slowly, concentric focus, and he used his other hand to release the exerciser. Oh, sorry. To squeeze slowly, concentric, and to release it slowly, eccentric. Release it quickly. Yeah, release it quickly. That's eccentric. Oh, I got mixed up, didn't I? So I squeeze slowly and release quickly. That's concentric focus. And with my right hand, I squeeze quickly and release slowly. And that's the eccentric focus. And the results were tabulated daily using an electronic hand dynamometer to measure the grip strength. That's that thing. Cost me about $30. I'm sure it's cheaper in Vietnam. Okay, so let's go on to methods and materials. For a big experiment, this will be a big section, okay? For our very simple experiment, it will be a short experiment, short section. Quoting from Indiana University again, the methods and materials section provides an overview of any equipment, apparatus, or other substances used in the experiment, as well as the steps taken during the experiment. Okay, step 1, step 2. If using any specific amounts of material, make sure the amount is listed. So that means other people can repeat your experiment to test your work. List the steps taken as they actually happened during the experiment, not as they were supposed to happen. You're dealing with the real thing, not what you would like to happen. So if written correctly, another researcher should be able to duplicate the experiment and get the same or very similar results. In a scientific paper, most often the steps taken during the research are discussed more at length and with more detail than they are in lab reports. Okay. Okay. Well, in our very simple experiment, the methods and materials are also simple. And the method was also simple. Um, what I did was to use a hand grip exerciser at different points on my fingers. All right. So in the first grip, a hand grip using only the finger sections from the fingertip to the first joint in each hand was used. And in the next grip, B, a hand grip using only the finger sections between the second and third joints of the hand was used. And that's where you can get a strong contraction. Okay. Then for the third grip, I used my thumbs. So a hand grip C, a hand grip using only the thumb section from the thumb tip to the first joint of each hand, not so strong. And D, a hand grip using only the thumb section below the first joint, okay? Squeezing, a little bit stronger. Okay, so that was the method for gripping. So what I did, a daily procedure of the experiment was exercise each grip position in each hand 10 times, twice a day. Now, the left hand grip involved squeezing each grip position slowly to the maximum, then releasing the grip quickly. Squeeze in slowly, release quickly. The right hand grip exercise involved squeezing each grip position quickly and then releasing slowly. Remember, that's the eccentric contraction, releasing slowly. And after all the grip exercises had been completed, using the grip exerciser device, all grip positions on each hand were tested once, just once again, using the hand dynamometer. And again, you know, the hand dynamometer tests were completed using a slow squeeze on the left hand and a fast squeeze on the right hand with a slow release. And the hand dynamometer results for all the grip positions were recorded twice daily on a spreadsheet, and any changes noted. Okay, so nothing very complicated there. What about results? Now, quoting Indiana again, the results show the data that was collected or found during the research, obviously. Yeah. Now, Probably you'll have graphs and diagrams, but you also need to explain in words the data that was collected. By the way, the reason for that is that some people are very good at reading graphs and spreadsheets and stuff. Other people understand words better. If using graphs, charts, and other figures, present them in the results section of the lab report. Okay, so all your pretty diagrams and tables and so on, you should put in the results section. And you can also put in there any calculations that you make to understand the data. You have to explain your calculations. So, okay, our little experiment. The result of the hand grip experiments are shown in figures 1 and 2. That's on the next slide. And raw dynamometer readings were entered on this spreadsheet. And then the tabulation was then converted to a graph showing changes in strength for the 8 grip positions over 46 days. So, okay, as you see, when you look at the graph, hey, not very impressive changes, eh? Well, a little bit in the beginning and then, well, nothing. The strongest grip was obviously my left hand. That's the high line on the chart. So those are fingers, and these ones are thumbs. Okay, and thumbs are not so strong by themselves. So what was the result? After a slight initial increase, all grip positions in either hand showed no significant change in strength over the 46-day period. Now, notice that when I'm writing like this, I don't say, I found. It's not personal, okay? So you have to leave all the I's out of it. In a talk like this, of course, I can say I. But when you're writing a STEM report, you don't put in I found, I believe, I think. Okay, so no significant change. Thus, the hypothesis that hand grip strength can be increased, A, more quickly, and B, to a greater degree by concentrating on eccentric muscle release rather than concentric muscle release, contraction or release, was not demonstrated in this experiment. So the positive hypothesis we didn't demonstrate. Okay. Now, after you get your results, you go on to a discussion of what your results were. And as Indiana University puts it, the discussion section is one of the most important parts of a scientific paper. It analyzes the results of the research and is a discussion of the data. If any results are unexpected, explain why they are unexpected and how they did not affect, or how they did affect or did not affect the data obtained. Right? So you analyze the strengths and weaknesses of the design of the research and compare your results to similar research, if there is similar research. If there are any experimental errors, analyze them. When you're doing work over a period of time, you're sure to make some errors. So you have to mention them and explain them in your results and in the discussion. Explain your results and discuss them using relevant terms and theories. Okay? Relevant terms and theories. That means the usual language to talk about this kind of thing. And that's often different from the words you would use in the street with friends. So you're writing a discussion, again, There are some questions you try to answer. What do the results indicate? What's the significance of the results? Are there any gaps in the knowledge? Are there any new questions that have been raised? That happens in good research quite often. Okay, well, back to our little experiment again, sample experiment. Possible limitations of the demonstration experiment, many of them. A single experimental subject, one person, is a very weak base for any scientific conclusion. You know, normally you would have a group of people. The larger, the better. Human beings are very variable. B, the amount of daily exercise for muscle strengthening may not have been optimum. And the 46-day experimental period may also have been too brief to show useful changes, okay? So 10 squeezes twice a day is probably not enough, you know? And the amount of daily, 46 days is not a very long time. Sometimes you can get results quickly, but sometimes it takes much longer, okay? And me, you know, the age of the experimental subject. Hey, I'm 77 years old. I'm ancient. So that might have influenced the degree of muscle strengthening. There is research, though, to show that you can get stronger muscles at any age. It takes longer, it's slower, but it can be done. And the experimenter may have misinterpreted existing experimental evidence on concentric muscle contraction and eccentric muscle release. And indeed, there's some existing experimental evidence reports which seem to have conflicting conclusions. That's very common. And it's very likely, you know, that I misinterpreted the results. I'm not a sports scientist. Okay, all we're doing here is illustrating a process. The statistical analysis of outcomes may have been flawed. In fact, I've attempted hardly any statistical analysis. All I've done is given you a graph, okay? When you're doing your stuff, you'll be doing far fancier things, okay, with different kinds of statistical models. And, you know, there may have been weaknesses in the experimental design overlooked by the researcher. Now, I said I'm not a sports scientist. It's likely that the actual hand movements did not properly exploit the differences between concentric and eccentric contraction. When you move your fingers, it's not a big movement. It's not like doing push-ups or something like that. So I mightn't have done it right. And there's actually a very good video by a guy called Casturo on YouTube. The link is at the end. If you're interested in this, I invite you to have a look at it because he knows his stuff. And it's quite a good critique of the sort of thing that I was doing. All right. Okay, so at the end, you have your conclusion, the conclusion to your experiment. The conclusion is a summation of the experiment. You know, you sum up everything. It should be clearly and concisely. It should clearly and concisely state what was learned and its importance. Concise, that means brief, not long. Yeah. You say what you mean clearly in a few words. And if there's future work that needs to be done, it can be explained in the conclusion. Okay, where do we go from here? My experiment again. The experiment was a simple demonstration of research method. That was our main point, right? Just to show you the process. The simplicity itself meant that many problems which arise in the method and interpretation of more complex problems did not arise in this experiment. You're going to find it much harder than me, okay? Because what you do probably won't be so simple. However, as a demonstration, this thing has served its purpose. Now, the hand grip strengthening experiment in its own terms, as for strengthening muscles, did not establish the positive hypothesis that eccentric muscle contraction is more efficient than concentric muscle contraction in strengthening muscles. So we've said this before, but in the conclusion, we're repeating it again, just to be clear. And if you like, it weakly established a negative hypothesis that neither eccentric nor concentric muscle contraction had an advantage over the other for muscle strengthening. That's a weak conclusion because there was little significant muscle strengthening of any kind. All right. So in the future, if you want to repeat this experiment, a future repetition of the hand grip experiment could be more rigorous. It's more thorough, more careful, by A, increasing the number of daily repetitions, B, increasing the number of experimental participants, not just one person, C, extending the duration of the experiment, not just 46 days, and D, controlling the hand movements more carefully to distinguish concentric and eccentric contraction. And E, and you can do this better than me, a more sophisticated statistical analysis of changes would be beneficial. Okay, so that's the end of our story as far as the sample experiment is concerned. Now, references. Usually you're not the only person in the universe who has done some experiment or some bit of research on a topic. So, as Indiana University says, when any outside sources to support a claim or background information are used, those sources must be cited in the references section of the lab report, of a lab report even, and scientific papers will always use outside references. It's really important to quote references. Otherwise, people might accuse you of stealing their research. If you use other people's stuff, say thank you. That's what references are about. And also other people can go and check the references. Okay, so we were doing two things in our sample experiment. So the references quoted in this paper are not properly comparable to the references found in regular research papers. Normally, a research paper would quote other research only from refereed papers in recognized specialist journals, as well as other specialist publications. So not anyone on the street like me who just put something up on the internet and say, hey, look at this. The stuff you use, the references you use in research have to come from a, respectable source. They're in every field. There are certain recognized journals. And that's where you get your references from, usually. Okay? People have trouble believing you otherwise. And it's important for promotion inside a university or somewhere like that. Now, the materials referenced here, by me, are deliberately chosen from open internet sources. with no particular attention to their quality. I've given some references that anybody anywhere can go and find on the internet. For quality journals, quite often you will need a subscription, or your university will need a subscription. The stuff I've given you, you can find anywhere. So the aim here has been to make some background information and ideas available to the widest possible group of non-specialist readers. Okay, doesn't mean what is here is wrong, but it's not quoted in an official journal. Okay, so I don't need to talk through a bunch of references. As you see, I went immediately to Google. In China, they would go to Baidu. In Vietnam, I think you can still go to Google. Okay. The British Council, which is in Vietnam too, has done work on this, as you can see. Okay. There's the Indiana University reference, and a whole bunch of other references, some from Vietnam, as you see. So those were ones about writing a STEM paper. But of course, I also needed source material, references, ideas for this demonstration experiment. Eccentric versus concentric muscle contraction. So there's Kastura, whom I mentioned before. He's a very, very good exercise scientist. Then some other references, some just people writing blogs who are interested in this particular area. And often they know quite a lot because, you know, it's their life. They're not academics, but, you know, for this sort of thing, that's what they do. Nosaka, Ken Nosaka was the guy I quoted at the very beginning, and he's what I've based the sample experiment on. His paper was actually part of a much bigger paper with many authors. I can recommend Science Daily because what it does is to have short summaries of scientific research in many areas, but it always gives a link to the original research. You know, if you want to go and check it out in depth, you can learn a lot about science and about the world by looking at Science Daily. There are some similar websites to Science Daily also, okay? Okay, so these are just other references. And one that applies to me, this particular one, the full reference is Ying Chia Wang there, shows the decline, the decrease in strength, grip strength in people as they get older. So, hey, I'm way down the bottom of this chart somewhere. I'm not 20 years old anymore. Okay. Now, I said at the beginning that my specialization was language, writing. So I'm both a writer and a teacher of writing and language to people. I've stuck an appendix on the end here, which is a very brief summary of a few writing tips. Appendix 1, writing a STEM paper in a second language. So this talks about how to write a STEM paper. Some kinds of advice apply to writing anything, of course, and some kinds of advice are special to writing about science, technology, engineering, and mathematics. We'll have a quick look at both, A, the general writing technique, and B, STEM writing technique. You can't do B well unless you can also do A. And by the way, this is a weakness for many very clever researchers who speak English as a native language. Their math is brilliant. You know, they're great engineers or scientists, and they write terribly. So That's a handicap because the information doesn't get in the ideal world, in the ideal way to the rest of the world. So yeah, you need to learn to write anything, and then you can write good STEM papers. So writing ability is a psychological habit. You know, you've all learned to talk your first language. You didn't even know you were learning it. It's something you've done from infancy, and it's very, very easy for you to do. Writing people suffer trying to do because it's not something most of them do a lot. If you write often in any language, your writing will become easier and more fluent, just like talking. I find it sometimes easier to write than to talk. When I was 19, I wanted to be a journalist. So one day I asked a famous journalist, and he gave me advice. He advised me to write 1,000 words per day on any topic for 100 days. And he said, the first 100,000 words, first 100 days, it'll be trash, But after that, I would be a writer. And, he was right. He was correct. I still have some of that early writing that I did, and I'm embarrassed when I look at it. It's not good. But it was the process of learning to write. And, whether you're writing in Vietnamese or in English or in any language, this psychological process is similar. Write a lot in Vietnamese, for example, okay? Then it'll be easier to write in English. You'll have the psychological habit. And always think of who's going to read your writing. Your readers cannot read your mind. State your purpose clearly. Explain briefly what your article will discuss if you're writing an article, and what it will not discuss. When you're speaking, when you're having a conversation, the person who's listening to you knows the social situation. They know what you're talking about. They see your body movements. With writing, you don't have all that. You have to give them that background so they know where you're coming from. And make your writing clear and interesting. Again, like talking, here I'm talking formally. I have to, right? If I talk to my friends over a cup of coffee, my language will be a bit different. And what is interesting to my friend won't be interesting to people doing this topic. So clear and interesting will be different for different kinds of readers. Therefore, know who you're writing for. For example, are they colleagues in your profession? Are they the general public? And so on, okay? So think about who you're writing for. And next, organize any ideas you have before you write. Those ideas and that organization will change as you write, but you need a starting point. You continue to reorganize your ideas as your writing progresses. And this includes adding in new ideas, which you are sure to get, right? And this is important. When you think you've finished writing, put the paper away for a few days. Forget about it. Take it out of your mind. Then come back later and look at the organization of the ideas again. Look at it like a stranger. There will be things you want to change. Doing this paper, I did it exactly like that, And I came back and I thought, no, I can't do that. I can do this. Oh, I made a mistake there. Even a native speaker does this all the time. And it's especially true if you're doing it in a second language. Right? And the best way to get ideas is to organize to organize ideas is to make lists of questions and sub-questions, questions about questions. And this applies at every stage of research and writing. You know, for 11 years, I've been running what I call a meetup, people who come together to talk about ideas. And I've learned a few things. I've learned that very, very few people are good at making questions. Please learn to ask good questions, practice it. Then you'll be a much better researcher. The answers you get will depend upon the questions you ask. A few people are very good at asking complex questions. Most people need a lot of practice. What is your questioning skill level? They should run university courses on this, you know, really. And if writing is a formal process, of course, there are different kinds of writing. Some is more formal than others. Writing a STEM paper is very formal. But all writing is durable. That means it lasts, unlike speech. Formal language mistakes become obvious. Language mistakes in your writing makes your writing look less credible, even if the ideas are good. People make social judgments about errors in writing. They really do. Maybe they shouldn't, but they do. By the way, in speech, even speaking English for me or Vietnamese for you, you make many errors. I've researched this. I recorded a housemate I had once. He was a mathematician, you know, and I recorded him secretly. I recorded us both over dinner. And in half an hour, he made more than 300 errors. And when I wrote it out later, he wouldn't believe me. English was his first language. We all do this, but we don't notice when we're talking. When it's writing, you see the mistakes. Therefore, always check your writing for grammar and style. Then put it away and come back and recheck it. Ask a friend to check it. Maybe hire a native English speaker if you're rich to check it, right? Not me. Okay, well, what about writing a STEM paper? That's a special kind of writing. A STEM writer is always neutral about a topic. A STEM writer is like a sports referee. You don't have favorites. Now, a writer about religion or politics or social events will usually have a personal opinion. These writers use personal language which supports their feelings. A STEM writer, a STEM writer will have personal feelings, of course, but these feelings will not be part of his or her writing. A STEM writer writes neutrally about facts, ideas, methods, and theories. Even if you don't like what you find out, you're neutral. You give both sides. You're a referee. Now, every branch of science, technology, engineering, and math has its own special conventions for writing about professional topics. There's a way people in your field write, a style they use, expressions they use. You have to learn those. Read as many papers in your field as possible. Ask yourself questions about how these papers are organized and what style of language they use. Do some practice writing to imitate these patterns. And something else, STEM writing, not all of it, but quite often, many STEM papers are written as part of a team. rather than as simply by one individual. If this applies to your field, try to find researchers who have done writing as part of a team. You know, teamwork is a different kind of scene in many ways. You have to get other people to agree to your style, you know, and to what you're saying, and so on. So ask people who've done this how they went about it. All right. Now, something a little more tricky. When I began to do research, there was no internet. Yeah, unbelievable, huh? Now you live in a different world. The internet is your friend. Somewhere on the internet is most human knowledge. The internet cannot write for you. No, even ChatGPT, you know, these new AI writing tools cannot really write for you. They'll seem to, but they won't. The internet cannot do research for you. However, the internet can help you to write and research. And back to questions, you just have to ask the right questions. If you ask the internet stupid questions, then you will get stupid answers. If you ask smart questions, then you'll usually get many answers. Not all of them useful. Some of the answers will be useful if you're awake. And some will not be useful to you. In fact, probably most will not be useful to you. So you must become skilled at finding useful answers. Now, for example, you know, here's a general topic, writing a STEM paper. I put it into Google one day and it claims to have given me 144 million results for that. I don't believe it. Most of the results will be useless. And you soon see that if you go through page 1, 2, 3, page 20 of Google's results. Some results, however, are very useful. Thus, the Indiana University, USA, offers a very useful information about how to organize scientific writing. And I've mentioned this again and again today. Now, don't just quote the reference, you know, don't be lazy. Go and check it for yourself. Maybe they had some good stuff and maybe some of their stuff was not so good. Check other links too. I'm not going to repeat all that information here, right? Oh, and here's the really bad stuff. And I know that in other sessions, you've looked at the ethics of research. So this is a little bit of repetition, but it's worth repeating. Some people steal other people's writing from the internet. This is called plagiarism. Plagiarism is a crime. There's no other word for it, right? It can get you expelled from university. If you've got a job, you can lose your job. Sometimes years later, you know, somebody will come along 10 years later and find this, and you ruin your reputation, you know. You lose your job. Sometimes politicians even lose their jobs when somebody finds they plagiarize material, you know. It's dangerous. Don't plagiarize. You can make use of ideas, okay? Admit where you got the ideas from and, you know, use the ideas in your own words. Now, here's something even worse, and this is fairly new. In the last few years, some criminal companies on the internet will write for a fee. They'll write your essays, write your research papers, even get you a university degree. It's unbelievable, you know. And as with plagiarism, you can lose your job and ruin your reputation. This is a big problem for universities. And for you, you know, if you do your essays or even get your degree like this, later it's a big problem for you because only fools use these companies. If you leave college without learning anything yourself, if you can't do it, then you know no more than a laborer, and you'll be useless in any professional job. That will soon become clear to the people around you, right? So don't hire someone to do your research, do it yourself. Okay, here's another appendix that I've added in. And again, these are very common research problems right across the research spectrum. They don't occur all the time in all research, but they're always in the background. One, research which does not prove what the research sponsor hoped to prove is just as valuable for science as research which does prove an effect. It's important to learn what does not work so that time and money is not wasted making the same mistakes again. Okay, you saw the mistakes I made with my hand grip experiment. Why would you make the same mistakes again? Do it better next time, right? But you wouldn't know unless I told you about my bad experiment. Now, unfortunately, in real life, such failed research, you could call it failed research, I suppose, might not be published, especially if the sponsor is a commercial organization. This can be very dangerous. You've probably heard of big pharma, that's big pharmaceutical companies. They have a research success in finding new medicines, which is very low, sometimes 1%. But if they find things which make their products look bad, they don't like to publish it. And sometimes this comes out 20 years later, and those companies get sued for millions or billions of dollars. You have to publish what doesn't succeed as well as what does succeed. And we mentioned, in complex research with big problems, it's really hard to prove something absolutely. You can only really trust research findings when they're repeated again and again in identical experiments. And however, perhaps because repeated experiments do not have the same glamour, they don't look as wonderful, as original research, it's often harder to obtain funding for them. If you're working in a university or something, you have to get funds, and if you just say, "Oh, we're repeating an experiment," your sponsors are not as enthusiastic often. It's harder to have repeated things published in leading journals also. Not always, they publish a lot of repeat stuff, but again, it doesn't have the same glamour, so it gets a bit harder. This is human psychology, I suppose. And, all kinds of people are researchers, 3 here. Like any other group of people, they come with all kinds of personalities. All of you people out there today, you're all different, okay? And you all have different kinds of pressures. So some publish faked research, as we mentioned, or even plagiarized research. And this can cause major problems for society and other people, ordinary people, and when such dishonesty becomes known, the researcher's own career is permanently ruined. And I'm going to give you a couple of examples here. The publishing arm of the Institute of Physics, okay, and that was a society founded in London in 1874. So it's a very famous journal. And, last year they had to retract nearly 900 papers. That retract a paper means you unpublish them. They were published, and they say, "Oh, sorry, that shouldn't have been published. It was a fake paper," and they take it out of their journal. 900 papers. That's a lot, just in a journal of physics. And okay, at least 497 of those retracted papers were claimed to have been written by Chinese researchers on topics ranging from chemical engineering to artificial intelligence. I won't get into politics here because this sort of thing happens in universities worldwide. But it is true that the Chinese government has been throwing a lot of money at research and rewarding people in universities for published papers. So, of course, that's a temptation. And it happens not only in China. Other papers retracted were meant to be from scientists in India and Iran, similar kind of problems, I don't know about Vietnam. The papers had been churned out by paper mills. That's like factories, okay? Operations that produce falsified research to order and arrange to have it published in Western journals. You pay them $5,000 or something, and they'll invent a research paper for you. So here, another famous journal, Springer Nature. It's one of the big ones. A German-British academic publisher is another victim. It said it had retracted 749 papers in the last 9 months. And they believe they came from these paper mills, these research factories, fake papers again. Yeah, a huge problem. So, ladies and gentlemen, don't do that. You're really clever. You can write your own papers and do your own research. Oh, you don't need to look at that. That's my bad table. That's a sample, right? Okay, I promised you a couple of assignments, 3. You can look at these in detail later. But of course, the best way to learn how to write a STEM paper is to do it, right? Either with real content from research or from other projects, or by attempting some simple or sample experiments, as we've done in this paper. So here are a couple of suggestions to get you started. Assignment 1, think of an experiment or an investigation in some other project which you would like to attempt, and outline the main steps you believe would be necessary in this project. And you can change them later if needed. I did this, right, for this paper. When I began to write this paper, I outlined my ideas first on a memory map. Probably you know about memory maps, okay? Memory maps are good organizing tools, and they're free. There are free memory map programs on the internet. So try using a memory map. Why not? That's what I came up with. No, you can't. It's too small to read. I know. That's okay. YAS actually has an image of the full-sized one of that. You can look at it later if you like. Okay, but you can make something like that for your own project. And okay, a beginning assignment, assignment 2, write an introduction and a methods and materials section for a project you propose. Again, it doesn't have to be huge, but it will give you the practice of writing. But be careful to self-edit after you've written the first draft. Like I said, put it away for a couple of days, go back and look at it again. Even experienced researchers never get everything right in their first writing draft. Okay. And the third one, okay, fixing funny English. If you're writing in English, this is a way to fix your mistakes. Now, I've been teaching and lecturing for 40 years, and I've fixed a lot of bad English in that time. And I found it's mostly a waste of time for me to fix other people's bad English, to correct it exactly, because they look at it and they say, oh, thank you very much, and forget it. And they make the same mistake again. So here's what I do now. What I do is to take, say, a piece of writing from an English learner, and I put it in Microsoft Word and turn the text into a table. You can do this really easily, narrow the image on the page and put a line feed, just press enter at the end of each line. So that makes a whole lot of lines. And then there's a menu in Microsoft Word where you can turn the text to table. So you turn the whole bit of writing into a table and then add a column on the left. And what I do then is to look down down the column with all that writing, and in each line where I see an error, I put a cross in the left-hand column. And I don't mark where the mistake is or what the mistake is. Yeah. So I put a cross. Yeah. And this means the writer made an English language mistake in that line. Now, this is from a friend who speaks English as a second language. She sent me this a little while ago, and I sent that back to her. And she said, hey, what are you doing? I said, you find a mistake. She said it took her 2 days to figure out what she had done wrong, but she remembered later. So what I'd like you to do, after you write your introduction and method, make a table like this. Give it to someone you think who writes fairly good English, not me. and ask them to do this, look at each line and put a cross where there's a mistake. Then ask your friend, no, I told my friend to figure out the mistakes. Okay. The person who finds your mistakes, don't let them tell you what the mistake is, Often they want to tell you what you did wrong. Don't let them do it, okay? You go away and scratch your head and figure out what mistake you made. Sometimes you can't figure it out. So then go and ask somebody else and ask another person. And it's a nuisance. It's a trouble. But the trouble makes you remember the mistake. And next time you won't make the same mistake. Okay? So that's just what I said now. Okay. Well, thanks very much for listening this long. I hope it wasn't too long. Maybe we'll need to cut something out. But remember, I also said this would be published so you can read it all later. Well, good luck. Thank you for listening, and goodbye for now.